we are looking at chapter 5 review. We're going to look at question number 5. So question number 5 says, find the standard form of a circle that has center 1, -3, and contains the points 2, 5. So just a disclaimer on the review before we go through this. I don't think there's any circles on the test. And this is a harder problem in my opinion, just because it's kind of out of the ordinary to give us a point, but it's a good thing to see. I feel like there was one of the problems that this could be useful on your test. I don't remember which one I was doing that I plugged a point in to find it. I think it was one of the graphs. So like one of the graphs, I think it was maybe the parabola. I can easily see where the vertex was, but it didn't give me like the focus or directrix or anything like that. And so from the graph, I had to like take one of the other points on the graph and plug it in for the x and the y to find the 4a in the formula, so that I would have the 4 points I was trying to write the equation from the graph. So I suppose this kind of could be a good example of that. Okay, so for our circle, we have x minus h squared plus y minus k squared equals r squared. So let's plug in what we know. So we know x minus 1, and we know y minus k. So minus a -3 is a positive 3. And we don't know r. So to find r, we're actually going to plug in our point 2 here for x, and we're going to plug in our point 5 in here for y. And now let's simplify it. So 2 minus 1 is 1, and so that's 1 squared, which is 1. And then 5 plus 3 is 8, so that's 8 squared, which is 64. So that's 65 equals r squared. So now I know what the equation is. If I really wanted to know what r is, it's the square root of 65, which is like a little bit more than 8, right? So possibly 8.1. So the question says, find the standard form. We're not actually graphing it, so we don't really care about that. We're not graphing it. All we really care about is having the equation. So x minus 1 squared. So what I had in there before I plugged the other numbers in, plus y plus 3 squared equals 65. So that is r squared, which that way we don't have that with the square root in there because it's the squared version of it, not just the r, right? So there's our standard form. Does that agree with my answer, Keith?
Yes.
Awesome. And I was trying to think if there's something else I wanted to say about this. Just for fun, if this were an ellipse instead of a circle, at this point we would take that 65 and we would divide everything by 65. So that we have a 1 here, right? And I mean, it's still a circle because this would be the square root. That would be square root of 65 going left and right from center. This would be square root of 65 going up and down from center. It's just putting it in the form of an ellipse, even though it's a circle. That's still, like, ellipses and circles are that closely related that it's nice to kind of look at that comparison. But this is the right answer. So we don't leave circles in this form. This is ellipse and hyperbola form like this. That's how we get it to that point. Sure, we'll do another example like that to see that. Okay, so you understand if you have just another point on the graph or a point somewhere, you can plug that in for your x and y value to find whatever you don't know about your equation, right? But then when you write your final standard form of your equation, you don't put that point in the equation, just h, k, and if it was a parabola, it would be a, If it was an ellipse, it would be, your A and B values or whatever. So just make sure you're leaving it in the standard form. You just use the extra point for that one step to figure out the values in your equation that you don't know.